Good morning, students. I welcome you to Brihan Mumbai Municipal Corporation Education Department, online education for English medium. For class 9, today I'm going to conduct a lecture for subject science, and the topic which I'm going to take is substances in common use, and in that we are going to learn subtopic that is radioactive substances. My name is Ms. Bushra Ahmed, and our Chief Nodal Officer name is Ms. Almaz Hanouri. Chapter number 14, substances in common use. See, in last chapters we have learned about some common substances such as salts, common salt, then baking soda, then we have learned about bleaching powder, then washing soda, soaps and detergents. But today we are going to learn about radioactive substance. Radioactive substance, you will tell me, ma'am, how this radioactive substance are used in a day-to-day life. Radio substances are used in making atom bombs, right? But no, that is a misconception. Radioactive substances are also used in day-to-day life. But in this lecture, we are going to learn about what are radioactive substances, what are the characteristics of radioactive substances, and then we are going to learn about how they are used in our day-to-day life. Okay, so first let's see about radioactive substances. What are radioactive substances? Elements with a high atomic number such as uranium, thorium, radium have a property of spontaneously emitting invisible, highly penetrating and high energy radiation. This property is called radioactivity. Now this is a very means huge definition and consists of lots of important points. So we will go by one. Let's see. Elements with high atomic number. Atomic number means what? Numbers of protons in the nucleus. In nucleus, how many number of protons are present? That is nothing but an atomic number. Okay. So the atoms in which such as uranium, thorium and radium, these all substances, uranium, thorium and radium, they are having what? High atomic number and have a property of spontaneously emitting invisible. Spontaneously emitting invisible means they are emitting some radiation, but it is invisible, means it is not visible in through our eyes. Then that radiation are what? Highly penetrating. Highly penetrating means what? They can penetrate through some other sheets or some other substances. Means they are highly penetrate. They can penetrate. They can go through. They can penetrate from one medium to another medium. Okay, so hence they are termed as highly penetrating. Then high energy radiation. The energy of that radiation is very high. So the property of this means elements which are having high atomic number, they are having property of spontaneously emitting invisible, highly penetrating and high energy radiation. This property is called what? Radioactivity. If someone will ask you what do you mean by radioactivity, so you will tell that the property of a atom that has high atomic number which can spontaneously emit invisible radiation that is very highly penetrating and having high energy radiation, that is nothing but radioactivity. Now next point. I think everyone understood what is radioactivity. Now a substance having this property is called radioactive substance. Now any substance which are having this property, above property, radioactive property, that substances are known as radioactive substances. Now third point, nucleus of radioactive substances, nucleus of radioactive element is unstable. Radiations occurs from an unstable nuclei. Now see, this is very important point. The nucleus of radioactive elements is unstable. Unstable means what? It is not stable. We can say that. But what is unstable here in the nucleus? Means the nucleus whose binding energy is very small, or which can't bind the elements in the nuclei, and that spontaneously emit that um, element from the nucleus, means then the nucleus is what? Unstable. If its binding energy is very less and it can spontaneously emit the element which is spreading in the nucleus, means that nuclei is unstable. If nuclei will be unstable, then only it will emit, right? Then only it will emit some radiation from it. Hence radiation occurs from which nuclei? Unstable nuclei. This question always asks why radioactive radiation occurs in unstable nuclei. Okay, so you can able to answer why it occurs, why radiation occurs in unstable nuclei. Now let's go to the next point. Three types of radiations are given out by radioactive substances. Now see, what are the three types of radiation? What are the three types of radiation are given out by radioactive substances? These are alpha, beta, and gamma rays. Now see, the three types of radiations are given out by radioactive substances, that are alpha, beta, and gamma. These three radiation are given out by radioactive substances, that are alpha, beta, and gamma. Now we'll go to the next slide. Next slide में जा रहे हैं. We'll go to the next slide now. My laptop is hanged, sorry.
Yes, ma'am.
Sir, I'm sorry, the laptop is hanged little.
Okay.
Yes, sir. Yes, sir. Now started. Sorry.
Okay.
And
Okay. No.
now we are going to the next topic, an introduction to the scientist. Now, what are the scientists which have worked on radiation, on the radioactive substance? Let's see now. The French scientist Henry Becquerel. The name of the French scientist is what? Henry Becquerel was studying pitch blende. Was studying what? Pitch blende, a compound of uranium. This pitch blende is nothing but a compound of uranium. Okay, he was studying that, he was working on this substance. Now what happened one day, what he has done, he has kept some unused photographic plates in a cardboard box in a drawer, and a key was lying on a box. Now what he's done, there was one cupboard. In that cupboard now there was one drawer. In that drawer one box was kept, and on that box there was a key lying on it, and on that key what he has kept, what unused photographic plates. First see, in the cupboard there was a drawer. In drawer the box was kept. On that box what was lying? A key was lying, and above the key what he kept? A photographic plate. He happened to leave the uranium compound on it. On the photographic plate, he just kept the uranium compound on it. Okay, now see what happened when he has just left the uranium compound on this photographic plate. So what the effect take place? After a few days, he washed the plates only to find that plates were cloudy and showed the shapes of the key. After some time, what happened, just when he just take out the uranium compound after some time and he washed that photographic plates, he found that the plate was cloudy and the shape of key was showed on the photographic plate. As this incidence occurs in dark, Becquerel inferred that the uranium compound might be emitting from their interiors rays like X-rays which penetrate substances. These rays were called Becquerel's rays. So what Becquerel thought that yes, from uranium, some rays such as X-ray, how the X-rays are penetrating now. So like uranium also some rays are getting out, some uranium is radiating some radiation, and due to which I found the shape of keys on the what? On photographic plate. After a few days, Madame Curie discovered a similar property in the compound of thorium. Madame Curie is also a scientist, and after some time it was seen that same property she has also taken out from which compound? From thorium compound. Now see, this is nothing but who this scientist is? French scientist Henry Becquerel. This is Henry Becquerel. This is Madame Curie, and this photograph is of Ernest Rutherford. Now we will learn about Ernest Rutherford. What he has worked on this radioactive substances. Ernest Rutherford in 1871 to 1937, a scientist from New Zealand, did research on radioactivity under the guidance of J.J. Thomson at the Cavendish Laboratory at Cambridge and McGill University, Canada. Now see, what happened? This scientist, Ernest Rutherford, he was born in 1871 and he died in 1937. He was a scientist from where? He was a scientist from New Zealand. He did research on radioactivity under the guidance of which scientist? J.J. Thomson. And which laboratory? Cavendish Laboratory at Cambridge and McGill University, Canada. He showed that nitrogen atoms could be split by bombarding it with alpha particles. Now see what he has studied. He had studied that nitrogen atom can be splitted up by bombarding what? Alpha particles. This experiment ushered in a new era in the field of physics. Now, as he has just researched on it that when he is bombarding alpha particles on nitrogen atoms, so some energy is released, some high energy is released, and this experiment just make a new era of physics. He make a much more theory in the field of physics. Now, let's go to the radiation back. Now, these were the scientists which we have worked on radioactive substances. Now, what they have worked, now we are going to learn that is nature of radioactive substance. Nature of radioactive substance. In 1889, Rutherford discovered that the radiations emitted by radium were of two types. Now, in 1889, what? Rutherford discovered that the radiation emitted by radium we all know, it consists of only two types. They are called alpha and beta. He found this alpha and beta. That alpha and beta are emitted by what? Radium substance. Now next scientist is Willard. Willard discovered the third type, namely gamma radiation. Willard is another scientist. He discovered then third type of radiation, that is gamma radiation. See, Rutherford had discovered only two, alpha and beta, while Willard had discovered third type of radiation, that is nothing but a gamma radiation. Next, see, when these rays are allowed to pass through two oppositely charged plates, they get separated. When we saw that alpha, beta, gamma, when this all are passed through what? Charge plates, positive and negative charge plates, they saw that there is some deviation in that part. They are getting separated. Now, how they are separated? What are the charges? What are the properties of this radiation? Let's see. This method was introduced by Rutherford in 1902. Now see, you will tell me here you have written 1889 and here you have written 1902. So what is this? Now see, in 1889, he found what? That there is two type of radiation, alpha and beta radiation are coming out. Here in 1902, what they have found that when they are passing it through from photographic plates, it is showing some charges, right? It is getting separated. Now see, Rutherford and Willard both combinedly studied what? The radiation emitted by radioactive substance. Now this both combinedly they were studying what? The radiation which are getting emitted by radioactive substances. For this purpose, the rays were allowed to pass through an on electric field and a photographic plate was held in their path. Now for this purpose, what they have done, they have allowed the rays to pass through an electric field and a photographic plate was held in front of that. Now see, it was found that radiation is divided into three types. Then when they have just make this arrangement, what they have seen that radiation is divided in three types. One type of radiation deviated slightly towards the negatively charged plates, while the second type of radiation deviated substantially towards the positive charged plates. What they have seen that when these rays were allowed to pass from electric field, so what happened? One ray was slightly deviated towards what? Negatively charged plate. That was negatively charged plate. So one ray was slightly deviated there, and while the other was what? It is substantially, it is more deviated towards the negatively charged plates. So with this, now what they have just see what they have conquered, that there is a ray which is negatively charged, hence it is deviating to a positive plates, and one ray it is positively charged, hence it is getting deviated to negative plates. Now however, the third ray of radiation did not deviate at all in the electric field. Now the third type of radiation which they were seeing, it was not getting deviated at all in the electric field. Now see, the ray, this much everyone understood that how these three rays are getting deviated in electric field. One is not getting deviated, one is deviated through positive plates, and one is to negative plates. Okay, negative charged plates. Now, the rays which deviate slightly towards negatively charged plates are called alpha rays. Now see, the ray negatively charged plates are called alpha rays. If alpha rays is getting deviated to negatively charged, means what will be the charge of alpha rays then? It will be positively charged, right? Because what? It is deviated towards negatively charged. Those which deviate substantially towards the positively charged plates are called beta rays. Now see, now the which is deviated towards what? Positively charged plates are called beta rays, and those which do not deviate at all are called gamma rays. Now see, one which is deviated toward negatively charged plates, that is nothing but alpha rays. Now with second one which is deviated to a positively charged plates, that is nothing but beta rays, and those which do not deviate at all, that are known as gamma rays. Now see, this is the construction they have made when they were doing the experiment. They have put one radioactive substance, might be uranium, might be thorium, or might be radium, in a lead box. Now why they have kept in a lead box? Who will tell me? Now see, they have kept in a lead box because lead box is with very high thickness, and from this lead box these rays cannot goes out. And here see, there is one hole, and this is nothing but a slit. This is nothing but a slit. In this slit, there is a small hole present in this slit, right? From this slit, from this small hole, now this radioactive substance is going through from this small hole, and from, see, there is a two plates, positive plates and negatively plates. Now So you can see that one ray is very much means substantially more is deviated toward positive plates, and this alpha rays is little much deviated, not much more as compared to this one. Now see, this blue ray is shown as a beta rays, and it is a negatively charged, while we can say that alpha is, see, alpha I have shown from which color? I have shown it from red color, and it is deviated toward negatively plates, and this is the yellow one which I have shown, that is gamma rays. Means here gamma rays is not deviated at all in the electric field. Beta rays is negatively charged, hence it is deviated through a positive plates. Alpha is positively charged, hence it is deviated to a negatively charged plate, and gamma has no charge, hence it is not deviated by positive and negative plates. Okay, now see, this much construction I think you have understood. Let's go for the next point. Now see, this is nothing but this is the characteristics of alpha particles, alpha, beta and gamma particles. What are the characteristics of alpha, beta and gamma particles? Now first we will see nature of alpha, beta and gamma rays. Now see, first point, nature. Current of alpha He means helium particles. What is this helium? Now see, alpha particles is nothing but a nuclei, helium nuclei. We can term this as alpha particle also, or we can term it as helium nuclei also. Okay, alpha rays can be termed as helium nuclei. It has a nature of helium nuclei. Second, we'll go to beta rays. Beta rays have nature what? It is nothing but an electron. It has, see, it is nothing but what? It is electron. Beta rays are electron. Where gamma rays are what? They are electromagnetic radiation of very short wavelength. Electromagnetic radiation means it is not deflected by electric field or magnetic field. Okay, it is not deflected by any field, as they are termed as electromagnetic radiation. This is the nature of alpha, beta and gamma rays. Now we'll go to second point, that is nothing but mass. Now mass of alpha rays are 4.0028 atomic mass unit. You can tell it just simply unit, or you can term it as atomic mass unit. Now see, 4.0028 atomic mass unit is of alpha particles, where of beta particles, what is the mass? 0.000548 atomic mass unit. 0.00054 at atomic mass unit is nothing but mass of beta rays. And gamma rays, what? Gamma rays having no mass. Gamma rays are having no mass, whereas alpha and beta rays are having masses. Now what are the charge? What are the charge of alpha rays, beta rays and gamma rays? Alpha rays are having +2 charge. Alpha rays are having what? They are having +2 charge. Why? Because helium atoms, helium nuclei is consist of how many number of protons? 2 numbers of protons. Hence the charge will be what? +2. Now the charge of electron is -1. Now see, the nature of beta rays is what? It is nothing but electron. Hence its charge will be -1. Okay, just don't learn the numbers. Just see why these are. You have to ask question to yourself. Why the charge of alpha rays is +2? Why the charge of electron beta rays is -1? Why we called it as helium nuclei? This all the number of question you will ask to yourself, the more you will get understood the concepts. Okay, so just ask question to yourself, ask question to your teacher, try to get the answer, then only you will get the whole concept of this. Okay, now see, This is having alpha rays are having +2 charge, beta rays are having -1 charge, while what? Gamma rays are electrically neutral. They are what? They are electrically neutral in nature. If they are neutral in nature, then only they are not getting deviated in electric field, right? They were not getting deviated like alpha rays and beta rays. Why? Because their charges are electrically neutral. Now, fourth point is velocity. What are the velocity of these three rays? Velocity of alpha rays is 1/5 to 1/20 times the velocity of light. Now see, velocity of alpha rays is 1/5 to 1/20 times the velocity of the light. Whatever the velocity of light is, alpha rays is 1/5 to 1/20 time of that. What is the velocity of beta rays? Beta rays are what? Is 1/5 to 9/10 times the velocity of light. Now velocity of beta rays is 1/5 to 9/10 times the velocity of light. And what is the velocity of gamma rays? It is same as the velocity of light. Gamma rays is what? It is having the same velocity, same as the velocity of light. Whatever the velocity of light is there, the same is the velocity of gamma rays also. Now see, this deviation electric field we have learned in the last diagram, right? That alpha rays are attracted towards what? Negatively charged plates. While beta rays what? They are attracted towards positively charged plates. Alpha rays are attracted towards negatively charged plates, hence they are positively charged. Beta rays are attracted toward positively charged plates, hence what? They are negatively charged, and it is not deviated. Gamma rays are not deviated, hence they are neutral. Now see, all the characteristics are linked one by one to each other. Why it is deviated? It is not deviated because it is what? It is neutral in nature. It is neutral in nature. Why? Because its nature is electromagnetic radiation. If you will learn one characteristics, you will get to learn second characteristic, you will get to learn third characteristics. Hence you have a clear conceptions of each and every characteristics of this rays, and it is very important. See, this nuclear physics subject is very interesting subject. If you go through it, just go through the small points. What are atomic numbers, what are atomic mass, each and everything. Okay, now see, let's go to the sixth one. Sixth one is penetrating power. Penetrate means going through from one medium to the another medium. When it is getting penetrate. See, when we are taking out X-rays, if we get fractures, right? We get an X-ray report. So how we get the X-ray report? Because that X-rays are getting penetrate through our body part, and we can examine where the crack is there, where the injuries are there, right? So same as the properties of X-ray, alpha, beta and gamma particles are also having a penetration power. Now see how much they are having the penetration power. Penetration power of alpha rays can penetrate aluminium sheet of thickness less than 0.02 millimeter. Means alpha rays penetration power are not that much as compared to beta and gamma rays. It can penetrate only less than thickness of 0.02 millimeter. Now, what is the penetration power of beta rays? Now see, beta rays can penetrate through the aluminium sheets of thickness 2 millimeter, which is 100 times the penetration of alpha particles. Now see, the penetration power of beta rays is more than the alpha rays. How? Because it can penetrate through the thickness of 2 millimeter, which is 100 times the penetration power of alpha particles. We see that alpha rays are penetrating from less than 0.02 millimeter thickness, but here beta rays what? It can penetrate through the thickness of 2 millimeter, right? Now, we'll go to the next gamma rays. Now these gamma rays are very highly penetration. Yeah, the penetration is very high. It can penetrate 15 centimeter thick lead screen, which is 10,000 times the penetration of alpha particles. Now see, whose power of penetration is more? Gamma rays. It can penetrate to 15 centimeter thick lead screen, and hence his power of penetration is how much times more than alpha particles? 10,000 times. 10,000 times the penetration of alpha particles. Now we'll go to the seventh point, that is ionization power. Ionization power means what? Ionization power is nothing but the energy required to remove an electron from a neutral atom. If one atom is neutral, so when the particles are getting bombarded on it, so it can have an energy to remove an electron from that neutral atom. That is nothing but that is termed as ionization power. Now see, ionization power of alpha rays are very high, while ionization of beta is low and of gamma rays are very low. This is the now see, penetration power was very low for alpha rays, while ionization power is very high for what? Alpha rays. Low is for beta rays and very low is for gamma rays. We'll go to the eighth point, power to produce fluorescence. Now see, power to produce fluorescence. Fluorescence light, we know right now in the modern era, we are just using fluorescence tubes also. Fluorescence lights are mostly for decoration purpose, for home light purpose, for various experiments also. We are just using what? Fluorescence. Now the power of fluorescence is very high in alpha rays. In alpha rays, power of fluorescence means the production of light is very high in alpha rays, while for beta rays it's very low, and of gamma rays it's again low. Means here beta rays can produce fluorescence very low, gamma can produce some, but the high amount of fluorescence which we get is from alpha rays. Now see, these all are the characteristics of alpha, beta and gamma rays. And see, I have made the symbols also here, how to represent alpha rays, beta rays and gamma rays. Okay, now we have seen nature, we have seen mass, charge, velocity, deviation electric field, penetration power, ionization power, power to produce fluorescence. These all characteristics are very much important of this rays. Okay, now this all the rays is coming out by which substance? Radioactive substance. Now we have learned today what are the radioactive substance and what are the characteristics of radioactive substance. Example of radioactive substance are uranium, thorium, radium. These all substance, what? These all substance radiate some amount of radiation, and what radiation they are emitting? They are emitting alpha rays, beta rays, gamma rays. Okay, this, I think this is very much clear to you right now. Now we'll go to the next one. Now see, alpha, beta and gamma, this we have taken characteristics also. Now go to the next slide. All the characteristics today we have learned. Now see, penetration also we have learned that it is getting penetrate from penetration power of alpha is very less, while of beta is much more than alpha rays, and the gamma is much, it is having a high penetration power. Laptop is hanged, sorry for the interruption students, some technical issue. Please start.
Hello, ma'am.
Sorry, sir. Laptop is again hang. I'm really sorry today. What's going on? I'm not getting.
Okay, no issues, ma'am. Actually, time भी अभी हो रहा है.
About to over. Yes, sir. My last slide was there, and that is not showing now.
Okay.
No, so students, this was all about today. The characteristics we have learned. Tomorrow we are going to learn what are the uses and what are the how this is used and the hazards of this radiation in our day-to-day life. So thanks for watching the sessions. Thank you very much.
Thank you, ma'am. Hello, students. कुछ doubts है?
If anyone has some doubt, can raise your hand and I can answer that also.
I think कुछ doubts नहीं है, ma'am. Thank you, ma'am. बहुत अच्छे से lecture लिया आपने.
Thank you, sir. Thank you very much.
Yes.